And the fourth question taken from last year's trial paper, Perak paper 2, and here we have a function f and the domain is 0 to 2. Alright, so for part A1 we need to sketch a graph for the function f using this graph. So let me use a scale for 1 unit for one box for both axes. So now we need to sketch the graph. So the most easiest way is to substitute 0, 1, 2 as x into this function. Then later on we find the value. Okay, so let's say 0, if I sub inside, it will become 1, right? So 0, 1. Then 1, if I sub inside, you'll get 2. 2, I sub inside, you'll get 5. Okay, then I join the points to form my f of x. Okay, quite simple. Right, part 2, we need to prove that whether the inverse of this function exists or not. So to prove inverse functions, we need to use this test, which is the horizontal line test. Okay, so from the previous videos I have said that if this line intersects the function for 2 or more points, it will fail. Okay, but as you can see here, it only passes through 1 point, no matter where I draw. Correct? So this means this f of x does have an inverse function. Okay, so we can say that inverse function of f exists as it passes the horizontal line test. Alright, part B1, using the same graph, okay, sketch the reflection, of the graph at y equals to x line for the domain 1 to 5. Okay, so from x1 to 5, we need to draw out this reflection and we need to use this y equals to x line, which is this. Okay, so to draw out the reflection, the easiest way is to reverse the coordinates. Okay, let's say this one is 0, 1, right? So for our image, we just need to switch these two coordinates. So it will become 1, 0. Okay, so we'll draw here. And same goes for the other 2 points as well. Okay, then you'll have your graph. Right? So for part 2, we need to express the functions for the graph sketched in B1, which is the blue line, using the function notation, which means the style or the format of our answer must be in this way: the function and also the expression. Okay, so how do we find this? Because now we don't know both of them. So if you go back to part B1, it says reflection and it says y equals to x. Quite familiar, right? Because this is one of the points I've mentioned in the previous video. The inverse function is the reflection of f in the line y equals to x, as you can see here. So now for this red line, and we use the black line y equals x line as the mirror, so the image of this red line will be the blue line, which is also the inverse function. So we already know the function that we are finding now, which is f inverse. So now we need to find the expression, or meaning we need to find the inverse function lah. So let me use the washing clothes method. So with our function here, we set this as the dirty shirt. So this dirty shirt is outside and inside is dirty, and we need to use these two equations to help us find the inverse, and let's let them as the soaps, right? So the second equation is just f moving to the other side, right? So the first step, which is to use the first soap, we need to apply it to the shirt, or meaning apply this first equation to our function. So f of x will be changed to y. Second step, flip the shirt, or meaning instead of y, we need to let x on the left. Then later on, third step, use the second soap, apply the inside of the shirt, or meaning need to apply this one back to here. So the x need to change it to f inverse of y. Okay, then later on we need to flip back the shirt, or means all the y's we need to change it back to x, and this is our function, our inverse function. And lastly, for part 3, we need to find the codomain of inverse function. Okay, so here for continuous lines, okay, so continuous lines means a line, okay, which is continuous, no breaks in between. So for this kind of lines, the codomain is equal to the range. Okay, so now we are finding the range for inverse. Okay, so if you look at the graph here, this one is range, right? So we need to look at the y-axis and we need to find the minimum value of y and the maximum value of y. So the minimum will be 0, okay, because it touches this line, and then the maximum is 2. So this means f inverse would be between 0 to 2. Right, there's another question here. What if there is no graph here? So how do we find the codomain if it asks, right? So in the previous video, I also mentioned this shortcut way, right? If we want to find the f inverse for the codomain or the range, we just need to find the domain of f, okay, which is given in the question here. This is the domain of f, right? So the only thing we need to change is just the x. Instead of x, we change it to f inverse of x.